Okay, getting into the last video of the night. In the previous video, we looked at the power and the quotient rule, and we ended that video with an odd looking term. And the thing that we were getting confused about is we had this derivative of k, where k was a function of g of x, and we didn't know how to evaluate that function if we wanted to take the derivative with respect to x. And if we compared terms, the two terms that we kind of took interest in were these terms here. And the reason that we did this is, recall if we had some power function, if we took the derivative, that would be equal to this. And if we consider x being equal to g of x, well, we kind of get that going on, but we get this additional term here. So we get this power rule-ish looking thing going on here. Now we know by the definition of a derivative, this is what we're going to be looking at. But how do we apply that if we have something like this function k? Because we could represent k like this, and maybe if we want to use that definition, do we put the h after g of x, like this? Or do we throw it into the x, like we did right here, and do this method? And it turns out, the way that you do this is the latter, because this definition is x plus h, not g of x plus h. So we get rid of that question mark, and this is what we're going to do. Now the trick that we do here is a little bit abstract, so again, trial and error is kind of useless. We can just give the answer. So we're going to multiply this entire thing by g of x plus h minus g of x in the numerator and the denominator. So realistically, this would just be equal to a 1. So it shouldn't change anything in that limit. And we know if we have the limit of a times b, we can break that up into the limit of a times the limit of b. But what we're actually going to do before we do that is switch the denominators, because we have multiplication, doesn't matter the order. So we switch those denominators, and then we split up a and b, per se, to have these two terms right here. And the easiest thing you're going to take away from this is that this term right here, well, that's simply equal to the derivative of g with respect to x. But now our first term, we're left with this odd thing. And this is where we need to kind of think of what this is representing in words, because I think it paints a better picture. And I'll leave it up to the viewer to think about what happens as h goes to 0, what it really represents. Or maybe we'll put in a little hint here of how the range changes over the domain at some infinitesimal level. And if you go back to the derivative explained video, you'll have a realization. And the realization is that this first term is a derivative. So what we're able to say is, if we have some function f that's a function of g of x, and we want to take the derivative with respect to x, well, first we have to take the derivative of that function with respect to g of x, and then we multiply that times the derivative with respect to x of g of x. And this leads us into what we call the chain rule. Think of it as we chain terms together when we have functions that look like this. And if this looks like something abstract, maybe you're asking that this seems niche. Is it? Is it really that complex? Is it rarely used? The answer to that is no. You'll probably use the chain rule most of the time. So we can consider a few examples. Let's say that we have some function y being equal to sine of g of x, and we want to look at y prime. So if we take the derivative with respect to x of y, we know that we are going to have the derivative with respect to g of x of y multiplied by the derivative with respect to x of g of x. And sometimes you might see this simplified to look like this, where you simply replace g of x with u, kind of makes the substitution look nice. But if we carry through with that, we get cosine of g of x multiplied by the derivative of g of x. And let's consider if g of x is simply equal to x, well, then the derivative of sine of x is going to be equal to the cosine of g of x multiplied by the derivative with respect to x of x. And again, we could plug in this g of x being equal to x here. We know that the derivative of x is going to be equal to 1 from the power rule. So what we get is that the derivative of sine of x is equal to cosine of x. And we know that checks out from the previous video. So our chain rule also holds true. Now, trig functions aren't the only thing that we have to deal with here. We can consider a polynomial function. So let's say x plus 1 squared. And we want to look at what is y prime. So there's two ways you could look at this. You could take this function and use the chain rule on it, And it looks like something didn't make it into the equation, so we added this tiny little term right here. But simply we represent g of x being equal to x plus 1. And then we follow through with our chain rule. And if we do that, we get 2 times x plus 1. You could put raised to the first power there, multiplied by the derivative of x plus 1. And we can do the other method. So we're going to take x plus 1 squared. We're going to expand that polynomial to have x squared plus 2x plus 1. Then we're going to take the derivative of that. Here we have basic power rules, and then we have a constant, so we know that that's going to go to 0. And the resulting term is 2x plus 2. Notice here that these check out. Again, the chain rule holds as we expect it should. And we can crank up the complexity just a little bit. But we're going to consider y being equal to the square root of the sine of x plus 1 squared. So now we have a function that is a function of a function that is a function of a function. I believe I said that correctly. So we got a messy looking thing here. And if we apply the chain rule, we just chain another thing on. So here we look at the function of f, and that is multiplied by the derivative of g, and then we multiply that finally by the derivative with respect to x of h of x. So if we do the first one, recall that we can represent the square root of x also being equal to x raised to the 1/2. So we can bring down that 1/2. We have our term here, and that's raised to the minus 1/2. So that goes here. That's multiplied by the derivative of what's inside of this. But now inside of this, we have a function h of x. So we kind of look at this right here. So that's going to be cosine of whatever this function is. And now we take the derivative of this inside here. Again, that's multiplied. So we would have 2 with the power rule times x plus 1. I guess you could also represent this thing as its own function. So you could have another function inside of this function, but I think this derivative is easy enough to do, because you could expand this out as a polynomial, as we did up here, to get this 2x plus 2 term, or 2 times x plus 1. And there's 2 more videos that we're actually going to do on derivatives before we move into a different thing, but we've covered a good basis that you would cover in a Calculus 1 course. If you learned anything new, found anything useful, please like, comment, share, subscribe. Helps the YouTube algorithm. We'll see you in the next video. Thank you for watching.